All right, hello and welcome to the last conic section, which is hyperbolas. We're probably going to do one more section of this chapter, practicing identifying the different sections, but this is the last specific one we're going to study, which is hyperbolas. So we've talked about parabolas and circles and ellipses. That's what we talked about last time. Today we're going to write equations of hyperbolas, and you're going to see that their equations look pretty similar, but their graphs look very different. So the new vocabulary you need to be careful of in this section is hyperbola, transverse and conjugate axis, foci and vertices and covertices, those we all had before with ellipses, and then something called a constant difference. Remember, with an ellipse it was a constant sum. With a hyperbola it's a constant difference. So just like an ellipse, a hyperbola is the set of all points in a plane such that the absolute value of the difference instead of the sum of the distances from the foci is constant. So if we look over here at this picture, the hyperbola is these two branches. Together they make one hyperbola. So here is one focus and here is another. Every point on the hyperbola, if I subtract that distance from both foci, that difference is always the same. Every hyperbola has two axes. One is called the transverse axis. The transverse axis is the longest one. So in this top picture, we have a horizontal hyperbola. In the bottom picture, we have a vertical hyperbola. The transverse axis goes through the hyperbola's vertices and foci. The transverse, or the conjugate axis, is the shorter one, and it makes this rectangle that we see here. And we'll talk about how to get those points in a minute, but the longer axis, or the one that goes through the vertices and the foci, is called the transverse axis. The foci always lie on the transverse axis, like we just said. The vertices are kind of like what we would think the vertices of a parabola, except these are slightly different shaped. They're a hyperbola. So you can see the vertices in both of these pictures. The covertices are on the end of the conjugate axis. So those are these C points that you see here. And we'll talk about how to get those in a little bit, but those are called the covertices. They basically make up this rectangle that you see in the middle. That rectangle and these other dotted lines that are the asymptotes, they help us to graph our hyperbola correctly. So our A and B values and C will help us get this rectangle. I draw the asymptotes through the diagonals of that rectangle, and that allows me to graph my hyperbola. Here are all of the beautiful equations. Again, remember, you will have this chart on tests and quizzes, but you need to be able to just interpret and use it and apply it. So notice that an ellipse was x squared over a squared plus y squared over b squared. A hyperbola looks really similar, it's just minus instead of plus, and notice again that it's equal to 1. So if it's horizontal, my transverse axis number, which we'll see in a second, goes under the x, and if it's vertical, it goes under the y. Why do I say transverse axis? Because my a value, 2 times my a value gives me the length of the transverse axis, similar to what we did with an ellipse, and 2 times b gives me the length of my other axis, my conjugate axis. And notice here, the equations of my asymptotes have to do with this b and a. So it's plus or minus b over a, x, or a over b, depending on if my hyperbola is vertical or horizontal. My foci are plus or minus c and 0. So when we figure out how to get the c value, which comes from this relationship down here, that c value is going to give us the points of our foci. All right, so we're going to practice writing an equation for this hyperbola. So what do we see in this hyperbola? We see my 2 vertices. We see the 2 foci, right? And we can kind of see where the asymptotes would go. But we're going to use specifically the vertices and the foci here to figure out the equation of our hyperbola. The center is the midpoint of the line that connects my vertices. So in this case, my hyperbola is centered at 0, 0. So that's my center. The value of A is from the center to a vertex. So A equals 2 units here from the center to my vertex. And then C, remember, is the distance from the center to a focus. So from here down to this focus, that's the value of C. So C in this case is 4 units. Now I need to find B. I have A, I have C, I don't have B. I know that C is 4 and A is 2, so we just plug those into this ABC relationship, and we solve. I get B squared equals 12. I only need B squared for my equation, so I don't have to finish solving for B, although we could. This is a vertical hyperbola. We can go back and look real quick. Notice it's opening up and down, so it's vertical. That means that the transverse axis number needs to go under the y. So y squared over 4 minus x squared over 12 equals 1. Be careful with this. In ellipses, it was always the bigger number that went under the direction that it was facing. With a hyperbola, the transverse axis, we kind of think of it as the main axis. It's not necessarily longer. The transverse axis is just the one that goes through the vertices, no matter if it's shorter or longer. So in this case, it's shorter, right? And that's fine. But since it's vertical, that transverse axis number, which comes from a squared, has to go under the y. And then minus my x term over b squared, which is 12. Okay, so you guys try this one, same idea. And again, notice this is centered at 0, 0. All right, your answer here is C. Here's the work for finding b squared so that you can write your hyperbola equation. Notice this is a horizontal hyperbola. And so my a value, which is 3, the distance from the center to the vertex, a squared needs to go under my x squared term since it's horizontal, and then minus my y squared term, which I put over b squared, which I get is 7. C is 4 because it's the distance from the center to the focus, and then I just use that equation to solve. All right, here we're going to write an equation given the asymptotes. My asymptotes here for a vertical hyperbola are y equals 3x and y equals negative 3x. My vertices are at 0, 6 and 0, negative 6. So we're going to write the equation for this hyperbola. Again, sometimes it's nice to just kind of sketch a graph and see what's happening. If my vertices are at 0, 6 and 0, negative 6, that means this is a vertical hyperbola. My center is at 0, 0. My vertices are equidistant from each other around the origin. Remember that midpoint of my vertices is my center. So here my center is 0, 0. Then I'm going to find the values of A and B. The value of A is the distance from my vertex to my center. So that's going to be 6 units. Now, here they say from the asymptotes, B equals 2. If you look back at the chart at the beginning of your notes, if it's a vertical hyperbola, the equations of my asymptotes are plus or minus a over bx. All right, so in this case, my asymptotes are plus or minus 3x. That means that a has to be, since I know that a is 6, I should say that, 6 over b has to be 3. Right, so that means that b has to be 2, because 3x is the same as 6 over 2x. Where do I get this 6? I know that a has to be 6 because of the distance from the center to my vertices. And since my asymptote equations are a over b, if a is 6, b has to be 2. I don't need the value of c to write my equation in this case. So I write my equation. It's vertical, so my y squared term comes first over a squared. A is 6, so 6 squared is 36. B is 2, so b squared is 4. That goes under my x squared term. And this is the equation for my hyperbola. Okay, so I want you guys to try this one. All right, your answer here is A. All right, so since this is a vertical hyperbola, my asymptote equations are plus or minus a over bx. Since my asymptote equations are 4 over 3, that means a is 4 and b is 3. This is a vertical hyperbola, so this one's pretty fast to write. My y squared term comes first. A squared is 16 and b squared is 9. All right, as with every conic section, I can translate if my center is not at 0, 0. So the h goes with my x, that moves my x value left or right, and the k goes with my y, that moves my y value up or down. Horizontal and vertical, all of that is still the same. When I have a horizontal parabola, my x value of my foci is changed by my c value, and the x value of my vertices is changed by my h value. Sorry, I should be saying h, not c and a. That h value of my center adds and subtracts to my foci and my vertices, and then the k value moves my co-vertices. It's the opposite with vertical. With a vertical hyperbola, the k value changes my foci and my vertices, and the h value changes my co-vertices. Notice that the equations of my asymptotes, these are in point-slope form. The slopes are still the same as they were before, b over a and a over b, but this time I have to use point-slope form and my point h, k, to get the equation of my asymptotes. So let's try graphing a hyperbola so we can see what happens here. All right, here we have our equation. From this equation, we know that our h is 3 and our k is 5. That means that the center is at 3, positive 3, negative 5. Then I need to find a, b, and c. From the equation, since the x is my positive 1, I know that this is my transverse axis number. This is a squared. That means that a is 2. And this is b squared. That means that b is 3. So I use my a squared plus b squared equals c squared relationship to find my c value. C squared is 13, so c is the square root of 13. All right, so step 3, I need to find my vertices and my foci. I know my hyperbola is horizontal because my positive term is the x squared term. The hyperbola is horizontal and the vertices are 2 units from the center because a equals 2. So if my center, just kind of imagine what we have here. My center is at 3, negative 5, right? So here we are at 3, and this is negative 5. This isn't a beautiful graph, it's just to give us an idea. And I know that my vertices have to be 2 units above this and 2 units, left and right, because this is a horizontal hyperbola, duh. So I know that I have to go 2 units to the left, so at 1, negative 5, I'll have 1 vertex, and 2 units to the right, so at 5, negative 5, I'll have my other vertex. So those are my 2 vertices. My foci are 3.61, or the square root of 13, units from the center, right? So my foci are going to be from this center, which is 3, negative 5, they're going to be 3.61 units this direction. So what they did here was they did 3 plus 3.61, and here they did 3 minus 3.61, because my other focus would end up over here. And this one would be over here. So those are my 2 foci. And now I need to find the asymptotes because they're going to help me draw my graph. So this is the equation for a horizontal hyperbola. B over a is my slope, or negative b over a. I know b is 3 and a is 2, so I can plug that in. And then I have my center point h, k. H is 3, k is negative 5, so I just plug that in. So these are the equations for my 2 asymptotes. Now I'm going to graph the hyperbola. The hyperbola is symmetric over the transverse and conjugate axes, and then I'm going to use symmetry to plot my hyperbola. So let's take a look at how we would graph this, okay? First, I always graph my center, and then I like to graph the asymptotes. So, actually I lied, I actually like to draw the transverse and conjugate axes first. So if this is my center, then I graph my vertices, which are 2 points on either side, right? And they give me this here. And then I know my co-vertices come from that b value, right? So remember that b is 3. So if I go 3 units up from my center and 3 units below my center, I get these 4 dots, my vertices and my co-vertices. And if you draw in a beautiful rectangle, as I did here, it's really cool because the asymptotes actually just go through the diagonals of this rectangle, and you can double check that it's the right point, but they go through this point, 3, negative 5, which is the center, and then they have the slope that you have in your equation. And so you can just graph them, and then you draw your hyperbolas in based on the vertices.